All right, students, we're going to be working on lesson module 5, homework 1. All right, so now we're going to look at factoring. All right, so now when it comes down to factoring binomials, we look at factoring, we look at it as a collective whole and then see what we can take out from the numbers and then from the letters themselves. The letters, like we talk about variables, they're handled separately from the numbers. We don't even worry about them together. So when I look at this and I see 14, 6, and 8, I know that 2 can go into all those, correct? So what we do is we identify the LCD, or the least common, the least common multiple of each of them. So I go ahead and do that. All right, we're going to go ahead and least common denominator. We're going to go ahead and pull that out. And then we're also going to look at the letters, right? Now the letters or the variables are all the same variable. That's number one thing that we need to see. The next is the greatest number of y's that I can pull out is 9 of them, because this one has only 9. So I'm going to put y to the 9th down here, and that's what we're going to be able to pull out. So it says factoring. We're going to go ahead and put that on the outside, what we determine as the greatest common factor of this set of terms. We're going to then divide each term by that which is the greatest common factor. So I'm going to go ahead and take and divide 14 by 2, subtract 9 from 21, and when we do that we get 12. And then we're going to go ahead and subtract 9 from 13, or I'm sorry, we're going to go ahead and divide it first. So 6 divided by 2 is 3. And then y is going to go ahead and get 4. And then we're going to go ahead and get 8 divided by 2 is -4. And then we're going to have no more y's left over. And then this becomes our answer. So it's factoring out a common binomial between these terms. And so it's the GCF, greatest common factor. Okay, so when we're looking at that, we see this is the answer. Okay, so that agrees. So when we're looking at this, the greatest common factor is just looking for what's the greatest number we can factor out, and what is the greatest number of y's or variables we can factor out. So in between 6, 15, and 21, 3 can go into all those numbers. So we're going to put 3 on the outside. And then x to the second power is the highest number of x's that I can pull out. All right. So now once I go ahead and do that, I'm doing the same idea like I did up here, is that I'm dividing each term by that. So 6 divided by 3 is 2. Take away 2 x's from 4 x's, we get x squared. And then we go ahead and do 3 into 15 goes 5 times. And then take away 2 x's from 3 x's. And then 3 goes into 21 7 times, and then take away 2 x's from 2 x's, and you're going to just get no more x's, right? It's x to the 0 power. So now we're going to go ahead and have that as our answer. See, now we can just go ahead and start generating our answers pretty quick mentally, if we just know how to take and find the greatest common factor. In other words, the greatest number that we can pull out from all of them, and then the highest number of variables. So this right here, all it asked us was for the greatest common factor. So all we have to do is determine it to be that. But I wanted to carry it on to where you can do it even mentally. Okay. So now it says factor the GCF out of the polynomial. So I've been doing it for you. Okay. I've been doing it for you here. I've been doing it for you there, even though it didn't require us to do it there. All right. So now when we look at the GCF for 10, 25, and 15, we can see that it's going to be 5. And then there's x to the second power. Again, we're just going to go ahead and divide each term by that. So it should be pretty easy to do it mentally when we take the value of the 5 and divide it into the 10. It'll give us 2. And then x to the third, because all we do is take and subtract the 2 that we're factoring out from the 5. So it's subtraction. That's why you get 3. And then you have 5x to the first, and then we have 3, and then that's it. And then we're done with that. So these move very quick if you understand what you're doing, okay? So factoring out the factor the following expression completely, we're doing the same idea. All we're doing is factoring out a binomial in these cases. So this one would be taking out a 2 along with the w to the 6th power. And then, so all you do is divide it and then subtract it and then divide it. All right, and then that's all we have left. All right, so these move very quick. All right, so now we're looking at factoring this, and this is going to be very repetitive, but it's the game. The strategy is to figure out the GCF. That's what this is why they're giving you so many. So I mean, I'm going to kind of go through these, but really it's going to be very repetitive. So I look at between 35, 10, and 6. All right, I'm thinking to myself, well, what can go into all of those? All right, 35. I mean, and the thing is that you got to look at it this way. It's 35. It's 1 and 35. Okay, and then 5 and 7, and that's the only numbers that can go into those. Well, none of these numbers except for 1 goes into the other ones. So that means that between 35, 10, and 6, nothing could come out of that except for just an x squared then. So what we do is put x squared and then put 35x to the 4th and then plus 10x to the 2nd, and then actually it's x to the 3rd. Excuse me, I thought that was a 2. So that's x to the 3rd. That would be x to the 3rd. My apologies. So then this would be taking out 3 to give us 1, and then taking out 3 would just give 6. So that's how that one works. Okay. So sometimes you don't have to take out numbers. That's what that was about. Is that problem was trying to address. You don't have to take out the numbers, and then you're just left with just whatever you take out with the variables. So with 35, 5, and 15, you can take out 5. Taking out 5, and that's all you're going to do with this. You can't take out a variable because there's not variable on the last term. So then you're going to get 7, x to the 7th, and then you're going to get 1, x to the 4th, and then you're going to get plus 3. So that's all we're going to get for that particular one. All right, so sorry about that. All right, let's go ahead and let's look at this one. So we're going to factor out a negative. Well, for number 7, you want to factor out a negative for this. Okay, because all of them have a negative. You don't want your remaining polynomial to have a negative leading coefficient. So we're going to pull out a negative 3 because 3 can go into all these, as well as an x to the 3rd power. And then so I'm going to go ahead and get positive 7 and then x to the 3rd. And then I'm going to get positive, and then it's going to be 3 into 3 is 1. So then it's just going to be x. And then I'm going to get a positive 1. So that's what we're going to be left with in that when we divide everything by this. Now, you'll notice how I'm trying to influence you. And by the way, you don't need that 1 in there. You don't need to put 1 here, by the way. I'm trying to influence you to determine your GCF and then to factor it out by mentally dividing. That's what I'm trying to get you to involved in. Because mentally dividing is really a powerful practice. We want to make sure that we're trying to do as much as without having to write everything down, because sometimes transcription errors gets in the way of success. So just letting you know that. So identify the greatest common factor. We don't have to actually factor it. It's not asking us to do that. It says do not need to factor. So I'm going to try to yield to that. So all we're going to do is factor out between 21, 6, and 3. It's going to be 3. And then And then I'm going to go ahead and factor out an x to the third power as well. So that's what we can factor by. So that's a GCF. I don't really need to divide it out, but if I did, I would go ahead and do exactly what I did all these entire times that I've been doing this. Now it gets a little bit busier when it comes down to multiple variables like this. Students start to like get a little bit weirded out by the fact that there's so multiple variables. We treat them separately. So first, treat each number separately, treat each variable separately. So we're going to go ahead and see that 2 can go into everything. So we're going to factor out a 2. Along with that, we see there's an x to the second power as the greatest number of x I can pull out from every one of them. And then the y, I see I have y to the fourth power is the greatest number of y's I can pull from all of them. Now, it says you do not need a factor again, so this would be our GCF. We would have our numbers here, or our terms there, whatever we end up with, okay? We don't need to do that in this particular case, but that is determining the GCF, all right? And then you would divide each term by that, and it becomes nothing but a thing. So here with this one's going to be 3, and then x to the third. We don't have to factor it. All right, now when we're looking at this, we don't have to factor this one again. This one is going to be 2, and then x to the third, y to the third. So again, we're looking at the numbers, and then I'm looking at the letters individually. So there's variable x and variable y. So then I see x has a fourth. I can't take 4 x's from 3 x's. So that's why we determine that x to the third is the greatest common factor, because it's the greatest number of x's I can pull from both of them. So that's what you should have been able to determine by the problems I did previously. So then the same thing goes with the y. The y to the third, I can't pull out y to the fourth from y to the third. So remember, I'm going to divide these, right? I'm going to be dividing them, and then I'm going to have to be having something left over kind of stuff. It has to have something left in the kitchen kind of thing. So now, when it comes down to 12, it does ask us to factor this. We're back to the same thing we've been doing before. We're going to factor out a 6, not a 6, but a 4 in this, and then we're going to factor out also of z to the 4th. So dividing 4 into 12 goes 3 times. Subtracting 4 z's from 6 z's gives us 2 z's left. Dividing 4 into 20 goes 5 times. And then we have no more z's left, and there's our answer. All right, so that's our work for that. Now factor completely. We're looking again for the GCF between 15, 21, and 6. See, some of you are not trained enough to be able to determine what the GCF between those 3 numbers are. But I mean, you just don't know your multiplication tables well enough. That's what that comes down to. I mean, so because like I see that immediately, I see 3 in all of them. But because I know that 3 times 2 is 6, 3 times 7 is 21, and 3 times 5 is 15. See, so I know all my multiplications pretty quick. But some of you are sitting here thinking, I can't do that. I don't even know what he's doing. Well, because you don't know your multiplication tables. And it's not your fault. Perhaps you just didn't memorize it enough, or didn't get somebody on your butt about it. So you need to go back to your multiplication tables. Restudying. When you have some time at work, just study your multiplication tables. It'll help you. I mean, your mind will just keep on building and growing stronger. So that's always a good positive thing. So I just gave you something to do on the off time. Now, 3 goes into 15 5 times. With 3 y's taken away from 5 y's, gives us y to the second. And then 3 goes into 21 7 times. And then y to the first. And then 3 goes into 6 2 times. And then there's no more y's left. So, you know, it's great when you just go ahead and subtract the exponential power, right? That's all we're doing. So that's all we have to do for that one factor. Now, between 21, 3, and 9, we should be able to see the 3 pretty quickly. I'm just going to say it's 3x, no x, because there's no x here. So then it's just going to be 3 as our factor. And then when we look at it, we divide 3 into each of these, and that's going to give us 7, 1, and 3. I mean, so I'm not going to write that one down. it's becoming very repetitive. Now this one, we're going to go ahead and look at this as 28, 8, and 4. 4 can go into all of them, so then I'm going to factor out a 4. I'm going to factor out x to the 4th and a y to the 2nd. Now I'm going to divide each term separately. So like, in other words, 4 goes into 8, all right, 7 times. And then we subtract 4 from 6 and get x to the 2nd. Y from y to the 3rd gives us a simple 1y. And then I'm going to now take and do 4 into 8 goes 2 times. So now I'm on to the next term. This is one term, the second term, and then the last term that we're going to look at. So x, take away 4 x's from 5 x's, we get 1 x left. And then take away y, 2 y's from 4 y's, we get y to the 2nd. And then we have 4 goes into 4 one time. Okay, 4 goes into 4 one time. So then that's going to give us 1. And then x goes into 4, x goes into that. That's going to leave us all with just 1, because isn't that the same exact thing that we have there? So x to the 4th, y to the 2nd, that's the same exact thing. That leaves us with just 1. So that gives us that answer. Okay, this is coming together. All right, so now when we're looking at the next part, we have 2 goes into everything. So 2, and then x to the 3rd goes into everything. So then I'm going to go ahead and have x to the 2nd plus 2x, and then plus 5, and then that's it. That's all we get for that one. So you can see these are moving pretty quick. Now again, you don't need to put 1 here. That's not necessary. Okay. Here we have 24 problems here. All right. Okay, now it's moving into factor by grouping. That's what, yeah. Well, we have one more of these and then factor by grouping, which is what I want to go into. Okay. Now, 5 goes into all that, so it's going to be 5. And then we have x to the 3rd and y to the 4th. So I'm looking for the lowest, highest amount of y's and x's we can take out. Weird way of saying that, but now 5 goes into 25 5 times. And then we have x to the 2nd, and then y, 1 y left. And then we have this. 5 goes into 10 2 times. And then we have 1 x left, and then 2 y's left. And then we go to the next one, and that's exactly the same thing. It's going to be 1 because it's exactly the same thing. I mean, we're dividing something by itself, and it equals 1. All right. Now we get into factor by grouping. So factor by grouping is a little bit of a different strategy. So all those exercises for the 17 problems that we just completed, they're all about taking and identifying the GCF and then dividing it out. Okay. Now we're going to go ahead and look at this, where we have z to the 3rd minus 2z to the 2nd plus 10z minus 20. Now this looks like something a little different than the rest of them. This is a 4-term polynomial. All right. So that when this gives you a clue that you should go ahead and group the first 2 terms together and group the second 2 terms together, and then go ahead and factor it out in each grouping. So factor out a binomial between each grouping. So I have a z to the 2nd that can factor out from both of these, as well as I have a 5 that can factor out between both of these. I actually have a 10 that can factor out. I'll take out a 10. 10 is probably better. I didn't see that. I'm going to be honest. I'm like, what the heck would I do? So now 10 can go into both of those. So when I do that, these 2 right here match up. And that's what we kind of want. We want that to match up. When I was mentally doing the 5 dividing, I'm like, that's not going to match this. And I'm like, oh yeah, wait, 10 can go in both of them. So anyway, we want these to match. So then what happens is I'm going to put 2 circles around these 2 things. These will come together as 1. So this comes together as this, and then this comes together as 1. Now, the way you write that, it doesn't matter if you write it this way or if you write it this way. It don't matter how you write it. It's going to give you the same answer, okay? So if you write it that way, no big deal. So that is our answer we're looking for, okay? And you can see that they wrote it this way, okay? So just heads up on that. It don't make a difference, okay? Now, looking at the next one, okay, we can do the same exact approach. So we will. We have CA minus 9C plus 5A minus 45. We group the first two terms together, second two terms together. We're going to factor out in C here. Factoring out C, we get C, and then we get A minus 9. Factoring in a 5, a positive 5 that is, we're going to get A minus 9 again. And these two match, so the two circled values here, I'm going to group them or put them together. And then I'm going to get C minus or plus 5, the two circled things first, and then I'll put the two things that are exactly the same together as 1. Do not write them twice, please, and don't put it to the second power. That's a no-no. All right, so you see how I get the same answer. So don't put, this is a common mistake people put. They put 2 here because they see 2 of them. Or they go ahead and multiply it by 2 and go like this or something like that. They do something goofy and it makes no sense. If you think about it, you're factoring this out as one thing. And, you know, just like if I was a factor out of 5, I would divide everything. So if I factored these out like I did the whole entire time I've been doing all this factoring out of binomial, I'm literally factoring out this binomial from both terms, right? And then if I divide in both terms by what I'm factoring out, this will go away, doesn't it? Leaving me with C plus 5. But I don't want to get complicated in that way of doing it. I don't want to do that. I just want to do my way of circle these two things, brings it as 1, and then make this come as 1. Okay? So factor by grouping is pretty quick. And the key that tells you that you're going to be factor by grouping is the fact that you have 4 terms. So I'm going to go ahead and I'm going to mentally go ahead and do, well, I could do all this mentally. Let's refrain from doing that. You'll be like, what is he doing? I don't get it. I don't understand. Okay, so I'm going to group these two together. So I'm going to factor out the common binomial is y. So I'm going to go ahead and do that. Factoring out a -3. And again, what prompts me to pull out a -3 again is that I want these two to match. And when I see that these are both negative, these are not negative. I want these two to match. I got to factor out a negative for that reason. It's just, I need these to match. Otherwise, the factor by grouping doesn't serve no purpose. So, and then again, these are my circle values. I'm going to put those together. And then I'm just going to put x plus 5. And there's my answer. -3, w to the third, -3, w to the second, w to the second, w. All right, I'm going to go ahead and factor this together, this together. I'm going to factor out a -3 w to the second. That's going to give me w plus 1. And then I'm going to factor out -2 here. That's going to give me w, or I'm actually factoring out a 2w, excuse me. And that's going to give me w plus 1 again. These two match. These are going to come together. And so I'm going to have -3w squared minus 2w. I can literally keep that just that way. And then I have this. Now, there's multiple ways you can write this. I mean, there are different ways you could have written this, but I'm saying that this is the best way, in my opinion. I could pull out a -1, or I could pull out a negative. In this, I could pull out a w. So that's probably something we want to do, actually. I'm going to actually pull out a negative W. Watch this. Negative W, and then I'm going to get W, or 3W, and I'm going to get plus 2. That's more appropriate, by the way. See, there's a W in everything, so the W should have come out. Matter of fact, I should have done that right in the beginning, is seeing that there's a common binomial first, pull it out, and then go ahead and do what we did. So that's more appropriate. So that's where this comes from. And then now we have our remaining values. But you see that I said there's multiple ways of writing this, but there is a common binomial that can be factored out. And if it's asking us to completely factor, then it would have been inappropriate to leave the answer this way. That's why it prompted me to go ahead and pull out the negative W. So something to be aware of. All right. Now with this one, that was a good question. I like that question. So this is grouped together, this is grouped together, and we're going to go ahead and factor out 9y. That's going to leave me with 1y, and that's going to leave me with minus 3. All right, I'm going to factor out a 15 here. That's going to leave me with this. Okay, now these two together comes together as 9y plus 15, and then it's going to give me y minus 3. All right, and the oh, I like this. Hold on, one second. Did I do? Oh, I showed the wrong answer, don't you? I was like, that didn't look right. Okay, now I was going to say here, 3 can go into all these, and this is, I mean, I'm trying to get through this, but this is a 3 can go into both of these. I was going to point that out. That I saw that, and this is, you should pull out the 3 amongst this. Okay, so that one is just like this with the W, you want to pull out the 3. So that's why the 3 came out. All right, now the next problem. So it's not factored completely if you left it the way I had it here, by the way. I would have gotten it wrong if I left it that way and I didn't catch it before I moved on. So you can do that by factoring out in the very beginning a 3. You can see that 3 can go into all. You factor out first, okay? So now let's go ahead and do this where I group these together, and x can come out, and then 6 can come out. And these two match again, so you're left with x plus 6. Almost falling off the frame here. X plus 9. All right, and the last one that we have, and I'll do that here as I save my page for the next lesson. But anyway, I look at 42p plus q plus 7, 6 qp. Now I look at this, right, and I see that I have these two terms. I could pull out a p, and I could pull out a 6. So what I want to do is I want to group these two together, okay? And there's a q here. So what I want to do is I want to arrange this, because if I group this together right here, these two, there's nothing I could pull out between them. So what I want to do is rearrange this. So I could I could make it become 6 qp plus 42p, group that together, and then group the q plus 7 together. Now when I do that, I can factor out the 6p between these two, and watch what happens when I do that. I'm going to put that over here. Sorry about this, it's a little bit wonky, I'm sorry. But it's going to look like this. And there's a p here, by the way. Okay, I factor out 6p, and I divide everything by 6p here. Then this is where the 7 comes from and where the p no longer there. And then I have nothing I can factor out here except for a positive 1. Because now these match. These match. Oh wow, I fell off the page. These match. Okay, here again, I went ahead and factor out a 6p, and then I go ahead and divide both terms by 6p. I'm left with q plus 7, and then I can't factor anything out between these two. All right, so I put as a plus 1. That's a critical thing that I put the plus 1, because remember the whole entire time I was circling these values to bring them together. Well, these two are going to be circled together and brought together as 1. So I'm going to have 6p plus 1, and then I'm going to have q plus 7. And then this is the answer we're looking for. All right. Now again, that should be q plus 7. I don't like this 7 plus q. That's a little weird to me. All right, and that concludes this particular lesson on how to factor common binomials as well as factor by grouping.